Earth was growing, but its birth was anything but peaceful. Around 4.5 billion years ago, the young planet was constantly bombarded by rocky bodies traveling through the solar system. Some were small, others were enormous. When these objects struck Earth, they released tremendous amounts of energy. The impacts could melt rock and throw enormous clouds of debris into space. With every collision, Earth became larger, and as its mass increased, its gravity became stronger. This stronger gravity allowed Earth to pull in even more material. But there was another important process happening deep inside the young planet. Earth was extremely hot. Much of its interior was partially or completely molten. Dense materials, especially iron, began sinking toward the center. Lighter materials moved upward. Over time, this separation helped create Earth's basic internal structure. At the center, a dense metallic core formed. Above it developed the mantle, and eventually, a solid outer crust began to take shape. But the surface was still incredibly violent. Volcanic activity was widespread. Gases escaped from the interior through enormous volcanic eruptions. The atmosphere was beginning to develop, but it was nothing like the air humans breathe today. There was no breathable atmosphere filled with the oxygen we depend on. The young Earth was still a harsh and dangerous world. And then came one of the most important events in Earth's early history. A massive planetary body may have collided with the young Earth. Scientists call the proposed object Theia. The collision was unimaginably powerful. Material from the impact was thrown into orbit around Earth. Over time, gravity pulled this debris together. Piece by piece, the material formed a new celestial body, the Moon. The exact details of the Moon's formation are still being studied, but the giant impact hypothesis is the leading scientific explanation, and the Moon would become a permanent companion of Earth. But Earth's transformation was far from complete. The planet was still hot. Its surface was still changing, and there was no sign of the oceans and living world that would eventually define Earth. So how did this burning planet finally begin to cool? After billions of years of violent collisions, something began to change. Earth started to cool. The young planet was still extremely hot, but its surface slowly began transforming from a world of molten rock into a harder, rocky crust. Volcanic activity remained intense. Huge volcanoes released gases from deep inside the planet, filling the atmosphere with water vapor, carbon dioxide, nitrogen, and other gases. But there was still no breathable air like we have today, and there were no oceans covering the planet. Then something remarkable began to happen. As Earth continued losing heat, water vapor in the atmosphere could begin to condense. Clouds formed above the young planet, and eventually, rain began falling. Imagine a world where rain could continue for incredibly long periods of time, falling onto a hot and newly forming surface. Water collected in low areas. Rivers began forming, and gradually, enormous bodies of water started to appear. The first oceans were beginning to take shape. But where did all this water come from? Scientists think Earth's water may have had several sources. Some water was likely released from Earth's interior through volcanic activity. Water-rich asteroids and other material may also have contributed to Earth's supply. Over time, these processes helped create a planet with vast amounts of liquid water. Earth was changing dramatically. The fiery surface was becoming more stable. The atmosphere was becoming thicker, and oceans were covering large parts of the planet. But Earth still looked very different from the blue world we know today. There were no forests and no grass, no animals, and no humans. The oceans were ancient and mysterious. The continents were still developing, and the atmosphere contained almost no free oxygen. Yet something incredible was about to happen. In these ancient oceans, chemistry was becoming increasingly complex. Eventually, the first simple forms of life would appear. But scientists still don't know exactly how non-living chemistry crossed the boundary into the first living systems. So when did life begin on Earth? And what were the first living organisms like? That mystery takes us into part 4. Earth was growing, but its birth was anything but peaceful. Around 4.5 billion years ago, the young planet was surrounded by countless rocky bodies left over from the formation of the solar system. These objects constantly crossed paths with Earth. Some were small, others were enormous. When they struck the young planet, they released tremendous amounts of energy. The impacts could melt rocks, create massive explosions, and throw enormous amounts of debris into space. But every collision also helped Earth grow. As more material fell onto the planet, Earth's mass increased. And as its mass increased, its gravity became stronger. That stronger gravity allowed Earth to attract even more material from its surroundings. Deep inside the young planet, another dramatic transformation was taking place. Earth was incredibly hot. Much of its interior was molten or partially molten. Heavy elements, especially iron, began sinking toward the center. Lighter materials moved upward. Over immense periods of time, this separation helped create Earth's internal layers. A dense metallic core formed deep inside. Above it, the mantle developed. And eventually, a solid outer crust began to form. But the surface was still extremely hostile. Volcanoes erupted across the young planet. Huge amounts of gases escaped from Earth's interior and entered the atmosphere. This early atmosphere was very different from the air we breathe today. There was no oxygen-rich atmosphere for humans to breathe. Then, something even more dramatic may have happened. Scientists believe that a large planetary body, often called Theia, collided with the young Earth. The impact was enormous. Rock and molten material were blasted into orbit around Earth. Over time, gravity pulled this debris together. Piece by piece, it formed a new celestial body, the Moon. The exact details of this event are still being studied, but the giant impact hypothesis is the leading explanation for the Moon's origin. Yet Earth was still far from becoming the blue planet we know. It remained hot, volcanic, and unstable. Oh, how did this fiery world finally cool down? And where did Earth's oceans come from? Earth had changed dramatically. The planet that was once covered in molten rock now had a solid surface, an atmosphere, and vast oceans. But there was still one major question. How did life begin? More than 3.5 billion years ago, Earth already contained environments where simple life could exist. The ancient oceans were very different from the oceans we know today. There were no fish, no whales, no plants, no forests, and there was almost no oxygen in the atmosphere. But beneath the surface of those ancient oceans, something extraordinary may have been happening. Scientists have proposed several ideas about how the first living systems could have developed. One possibility involves hydrothermal vents on the ocean floor. These underwater volcanic systems released hot, mineral-rich water into the surrounding ocean. They provided energy and chemicals that may have helped complex molecules form and interact. Another possibility is that important organic molecules formed in shallow pools, ponds, or other environments on Earth's surface. But the exact process remains one of science's greatest mysteries. At some point, chemistry became biology. But the exact process remains one of science's greatest mysteries. At some point, chemistry became biology. Simple molecules eventually became systems capable of maintaining themselves and reproducing. The earliest organisms were extremely simple compared with modern life. They were microscopic. They had no animals' bodies, no plants, and no complex ecosystems. But their existence changed the future of Earth forever. Over immense periods of time, these tiny organisms evolved and diversified. Some eventually developed the ability to use sunlight as an energy source. This process, called photosynthesis, would have enormous consequences. Photosynthetic organisms released oxygen into the environment. Slowly, over hundreds of millions of years, oxygen began accumulating in Earth's atmosphere and oceans. That change would eventually make more complex forms of life possible. But this transformation did not happen quickly. Earth's story was still only beginning. From a cloud of cosmic dust, to a molten planet, to oceans, and finally to microscopic life. Earth had traveled an extraordinary journey, and over billions of years, that tiny beginning would eventually lead to an incredible diversity of life. But how did simple microscopic organisms eventually become complex creatures, dinosaurs, mammals, and finally humans? That is where the next chapter begins. The story of Earth continues.